In this question, we're told that there's a vacuum between the plates, and the two plates are separated by a distance of 0.041 meters, whereby a potential difference is applied between the plates, and then we have this electron which is going to accelerate towards the other plate. So you are asked to identify what is the what would be the charge on the figure. Use the symbol positive or negative to indicate the plates, whether it's positive or negative. So since this electron is going to accelerate in that particular direction, it will mean that this must be a positively charged plate and this is a negatively charged plate, because this plate is going to repel the electron, as this other plate is going to attract that particular electron as it's going to move in that particular direction. Then we are supposed to calculate the electric field strength. Electric field strength between the plates, and give your units. You need to ask yourself, what is the formula for electric field strength? We know that electric field strength is going to be given by the potential difference between the plates and the distance of separation. But the potential difference is 58 kilovolts that was applied here. So which means that we are going to say this is going to be 58 times 10 raised to power 3 divided by the distance of separation, which is 0.041. And if you work it out, you are going to get your answer as 1.4 times 10 raised to power 6. 1.4 times 10 raised to power 6 Newton per coulomb. Newton per coulomb. Yeah, we can write the units there, Newton per coulomb, or it can be volt per meter. Volt per meter or Newton per coulomb. Determine the acceleration of the electron. Acceleration of this particular electron. What is it going to be? Let me just write the units here properly. Newton per coulomb or volt per meter, any of them. Then you are supposed to work out acceleration. Acceleration is going to be, first we need to work out the force. Force is going to be the charge times the electric field. The force this electron is going to experience is equal to the charge of the electron times the electric field between the two plates. So that will mean we need to know the charge of an electron. And in this case, we're going to focus on the magnitude. Then we're going to say force is given by this, but we know force, which is QE, is equals to the mass times acceleration, whereby here we're going to use the mass of the electron. Then this implies that our acceleration is equals to charge of the electron times the electric field that we have gotten at this given point over the mass of an electron, over the mass of this electron. So that is going to be 1.6 times 10 raised to power negative 19. That is the charge of an electron times the electric field, and the electric field we had gotten here times 1.4 times 10 raised to power 6. Then we shall divide that by the mass of an electron, and the mass of an electron is usually given as 9.11 times 10 raised to power negative 31 kilograms. So if you work out whatever we have here, you are going to get it as 2.5 times 10 raised to power 17 meter per second square. Power 17 meters per second square. So that becomes the acceleration of this electron across as it's approaching this particular plate. See you in the next tutorial.